Okay, this lesson we are going to talk about compound probability. So compound probability is the probability of two events that are compounding on one another. So simple probability is just, okay, you pulled one marble, what's the probability of pulling that color marble? What's the probability of pulling a colored tennis ball? It's just one thing that's happening. So compound probability means that there are two events happening. So we have different situations here. We have probability of A or B, and you guys know when you see the word or that you're going to add. Then you also have the probability of A and B. So the probability of A and B is those events multiplied together. Now we also have this situation where your two events, the two things happening, are mutually exclusive. And two events are mutually exclusive if they don't affect one another at all. So that would be like picking one marble out of one bag and then another marble out of another bag. Or one person that is a boy and one person that is a girl. Or if you have a brother or a sister. Your brother can't be your brother and your sister. It's either one or the other. They're exclusive of one another. So how do we actually find the probability of a compound event then? There's two different ways. So the first one is if A and B are two events, then the probability of A or B, which is right here, is going to equal A plus B. That's what probability of A or B is. A plus B. But if you have a situation where they're not mutually exclusive and you have an area that overlaps, you have to subtract that from your A and B added together. So if you have events that are overlapping, then the probability of those two events, A or B, is going to be both of them added up, and then you have to subtract the part that overlaps. But if there's no overlapping, so that's your second part there, then you simply just have to add the two events together to get the probability of event A or event B. So those are your two formulas to find the probability of A or B. So let's look at our two examples at the bottom of this page. And again, this might be helpful, or that handout that I gave you guys, the deck of cards, may be helpful for this lesson. It says a card is randomly selected from a standard deck of 52 cards. What is the probability that it is an ace or a face card? So we want to know what is the probability that it would be an ace or a face card. Okay, well, the probability of it being ace, how many aces are there in a deck? There are 4 out of 52 cards that are aces. Okay, it's or, so we're going to then add. So how many face cards are there in a deck? And remember, aces are not face cards. Face cards are the jack, queens, and kings. So how many total jack, queens, and kings are in your deck? And there's a total of 12. 3 in each suit and 4 suits all together. So now you have to think to yourself, okay, are there any times that an ace card is going to be a face card or a face card is going to be an ace card? No. Ace is an ace and a jack is a jack or queen is a queen, king is a king. There's no overlapping there. So you don't have anything to subtract. So it's just going to be 4 plus 12, which is 16 over 52. If you want to reduce it, it would be 4 over 13. And I like to write it again as a percentage. So 4 divided by 13 would give you guys a 31% chance of picking a card out of the deck that would be an ace or a face card. So in that case, this one was mutually exclusive. But what about number 2? It says a card is randomly selected from a standard deck again. But what is the probability that this card is a heart or a face card. So, probability that it is a heart or a face card. So, how many hearts are there in the deck? Again, guys, if you literally want to look at that handout I gave you and count how many hearts there are, that's fine. But 52 divided by the 4 suits is going to give you guys 13 hearts in the deck. So 13 total hearts out of 52. Okay, plus how many face cards are in the deck? We just said it above in the other example. How many jack, queens, and kings are there? There are 12. Okay, so I just magically got a deck of cards there. So we have our heart. Those are the 13 right here. We have our face cards. That's the jack, queens, and kings. Now it wants to know, okay, or I want to know how many of those cards are face cards and heart cards. Where is the overlap? Okay, so there are 3 hearts that I'm looking at that are also face cards, and that's going to be the jack, queen, and king of hearts. So there are 3 cards that are hearts and face cards out of the whole deck. So the hearts plus all the face cards minus where they overlap or they are the same thing. So 13 plus 12 minus 3 is going to give us 22 over 52, which reduces to 11 over 26, or as a percentage, a 42% chance that you would get a heart or a face card. So number 2 would not be mutually exclusive because there is overlap there. Okay, I'm going to do number 3 with you guys because it's a little wordy and it seems more complicated than it really is. So it says, last year a company paid overtime wages or hired temporary help during 9 months. So overtime or temporary help was a total of 9 months. So overtime or temporary help was 9 months. Overtime wages paid were 7 months. And temporary help was hired during 4 months. So it says, at the end of the year, an auditor examines the accounting records and randomly selects 1 month to check the company's payroll. What is the probability that that auditor is going to select a month in which the company paid overtime wages and hired temporary help? So we're trying to find the probability of A and B, events A and B, temporary help and overtime pay. Where do they overlap? That's what we're trying to find. So based off of our equation in that box at the beginning of our lesson, I know that the probability of the overtime or temporary help is going to equal the temporary plus the overtime minus where they overlap. So overtime or temporary help, they said, was a total together of 9 months. So the overtime and temporary is 9 out of 12. And that's going to be equal to the temporary help plus the overtime. So overtime was 7 and temporary was 4. So 7 over 12 plus 4 over 12. And that's going to equal, or I'm sorry, not equal. We need to subtract the A and B. So how many months was it both overtime and temporary help? So this is a lot easier than it seems, guys. So what were the overtime wages and hired temporary help? So what's 7 plus 4? 11, right? So 9 twelfths equals 11. 12ths minus however many is both. So 11 minus what is going to give you 9. 2. So 2 out of the 12 equals overtime and temporary help. So 2 divided by 12 reduces to 1/6, which is about a 17% chance that auditor is going to select a month where they were paying overtime wages and paying the temporary help. So you guys now need to try number 4, A, B, and C. And I'm going to skip down here to the bottom of the page. Okay, so the probability of the complement of an event. Complement is basically not the event. So if you're trying to find the probability of the complement of some event, it's going to be the probability that it's not that event. So it seems sort of weird that we would do this, but every once in a blue moon, if you're trying to find the probability of something, it may be such a large number that it's easier to actually find the probability that it wouldn't be and then subtract it from 1. So given the probability of an event A, the probability of its complement can be found by subtracting the given probability from 1. So your complement equals 1 minus the probability of your event. So we have 2 6-sided dice that are tossed. There are 36 possible outcomes because 6 times 6. If you had a dice that had 10 numbers or 10 letters on it, 10 times 10, you would have 100 outcomes. If you had 2 dice that had 8 numbers on them or 8 letters on them, there would be 64 outcomes. You're just multiplying them together to get the total outcomes. Then it wanted the possibility of the sum not equaling 8. So what's the probability that the sum would not be 8? Well, first, you have to figure out what are all your possible sums. So I wrote those down there. 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4. And I filled out that chart. So for letter A, it wants to know what would the probability of the sum not equaling 8 be equal to. Well, how many times does 8 equal, or is 8 your sum? 5 times that could happen, right? So the probability of the sum not being 8 is going to be 100%, or 1, minus those 5 times out of 36. So 1 is the same thing as 36 over 36. 36 minus 5 is going to be equal to 31 over 36. So you would have an 86% chance of your sum not being 8. Okay, what about letter B? It says probability of the sum being greater than or equal to 4. Well, if you look at this, how many sums are there greater than or equal to 4? If it's or equal to, we have to include it. So 4 and everything above it. So how many sums are there that are 4 or greater? 33. So 33 out of 36, which does reduce to 11 over 12. And that would give you a percent of 92. So you have a 92% chance of getting a sum that is greater than or equal to 4. So now you guys have practice to do. So try page 31 and 32, and we will go over it in class.